All right, we're gonna go ahead and begin our video here on chapter 2, input processing and output. Uh, we still have we have a few things to cover before we get into here, and I'm not going to spend this whole time on PowerPoint. We're going to be doing some demonstration and some other things. But one thing that I want to talk about is why are you learning about Python? What makes Python good? And where will you see use in it? Now, if you are, I guess to answer that is to understand a little bit more what Python is. Python is actually is not really what we call a programming language, although it is. It's kind of, we call it an interpreting language or a script language. And that means that another program interprets your code into its own code. What does that mean? Okay, well, Python was written with the C programming language. So it's just a program that reads your text and converts it, the instructions that you give in the Python scripting language, to its C counterpart. And essentially does the tasks at the C level for the C programming language. And that means that even though it's what I call like a super language, a tertiary language, which has quite a few capabilities of higher levels of not having to deal with some of the low level kind of stinkiness of like the C languages and some of the other low level languages that makes it difficult to use. And so what's good about it is that scientists love to work with Python because they don't want to have to learn a hard programming language like C, because it just takes too long and they're not that interested. And then also, since the C programming language actually is pretty much the fastest programming language we have out there. Python, even though it goes through this interpretation window, once it gets down to that C level of code for processing data for scientists, it's rather quick. So that's why data scientists love it if you're going into that information technology field, because they can actually process information to get some kind of result faster with Python than it would be to learn the C programming language, or even even if you knew the C programming language and started programming it, it would still take longer to do it in Python, because the whole idea of Python is to take all the multitude of steps in C and the complexity and simplify it into few steps that are not as complicated to complete the same job. And that's where Python comes in for data scientists. Now, for cybersecurity individuals, one thing that Python's good for is that rapid development. So a lot of times what you'll be using Python to do as a cybersecurity professional is to read in log files and do data analysis with those log files. And Python's really good at parsing information and tokenizing that information from those log files. And those log files, what they are is just like, if you have an Apache web server, who comes onto your server as that service, and how long they stay there, all these different metrics that you got coming to you from your services, web services, any other kind of service out there that gives you metrics of who's using the service and where and when. And Python is really good at quickly gathering that information, where you can quickly write a script to gather that information and then rapidly detect somebody in your network behaving badly, and then of course make some kind of adjustment to deal with that intrusion. And so that's where Python comes in. Now, if you're not really into IT and you're not really into cybersecurity, well, it's still a programming language. So when you learn Python, all the rules, most of the rules and the way things work are much the same as in every other programming language out there. So, even though you're going to hear me say it's a scripting language here and there, yeah, it's whatever. Yeah, but once you learn this language, you'll be able to break off into some other languages. There are some bad habits that you get into when you learn Python first, and that's the only thing that I will try to show you good habits as we progress. But just know that Python allows you to write really stinky code because it's the whole idea is we want it to work. We want you to be able to write bad code and have it work. That's the idea of interpretations and script writing, or interpreters and script writing. So let's look at the PowerPoint just to keep me kind of on the straight and narrow as we go through here. And one of the things that we're going to want to work with is input, processing, and output. So let's take, for instance, that input and processing and the output. What does that look like? And the way that looks like for all programming languages is, your main input device is the keyboard. So pretty much all your input will be using the keyboard. Now, if you have devices hooked up to your computer, yeah, you can get input from those other devices, scanning with a spectrometer as an example, some other things, but for most of what you're going to be doing, your input's going to be from the keyboard. And that starts with what we call ASCII code. Now, ASCII code is the map of your characters, because here's the thing that you want to remember in computer science and computers. Everything is a number. It doesn't matter what it is. It's a number. I'll show you something on the screen. I can show you how that's a number. If you zoom in on these images, they all have pixels that have a red, blue, green value, and they have a row and a column where that pixel is located in that image that you're looking at. So no matter what, everything on a computer, no matter, it doesn't matter. It's all a number. So even the characters that you type into the keyboard are numbers. So that's where we're going to kind of start and get an idea of kind of the different numbers that we have available to us. Well, you say, oh, there's 128 keys on the keyboard. That means there's 128 different numbers. And yes, there is. So this is pretty much the standard ASCII code key chart. Every computer out there in the world has this at the lowest level. No matter if you find it in China, it's still got this at the lowest level. They use special characters in Unicode, which is just an extension of ASCII code. So this ASCII code is pretty much what you're going to be dealing with for your input, processing, and output. The problem being is, you see here, value number 41 is giving the value 0. So when you're doing input, you're actually inputting these ASCII code characters. You're not actually inputting a number. It's a number. Duh, everything's a number. But the thing is when you enter a 1, it sends the value 49. That's what the value 1 is for an ASCII code character. So when you get input, the user is going to be entering the data in ASCII code. So if the user enters 10, 1, and 0, you have to go through a conversion to convert that 10 into an actual number. Because all programming languages work this way. From the user, you get a string. And you can work with that string, or if it's a number, convert that string into an actual number that you can then add, subtract, divide from. And then when you go to output that information, you convert that number back into a string so it can go out to your terminal through standard output. And standard output is pretty much how everything's done, even graphical user interfaces. So don't think that it's, your input and output that you're using is directly associated with even graphical user interfaces. So this rule is for everything. It could be a form-based text box on the web. You're going to get the input from a string on the keyboard, and then you would have to, if it was a number, you'd have to convert that number and then be able to process that number. So that's some of the stuff that we're going to be working with today for your input, processing, and output. So let's start with, let's go ahead and head back to a little bit on the PowerPoint, and then we're going to get into some demo time. And we're going to talk about some specific particulars with processing. But you know what? This stuff is just, strings, sequence of characters. Use your double quotes on that. Let's go ahead and just dive right into demo, and we'll come back to this in a little bit. I really would like you to get a feel for getting things from the user and then processing it and then outputting it. That's kind of my goal for today. Now, I like to use Visual Studio Code for Python. It's actually become pretty popular because it's fairly new and up to date. If you've got Spider or PyCharm, that's fine. Although one of the reasons why I like Visual Studio Code is because it's much easier to debug than some of the other editors that we have out there. So what I'm going to do is, this is Visual Studio Code, and I'm going to properly set up a program to write into Visual Studio Code. This is just, it started up. I haven't done anything with it at all. What I want to do to properly set up a development environment is I want to create a folder to hold my script. And I'm going to call this chapter, it's just CH. Okay, more options. Okay, rename. Chapter 2. Okay. And then what I'm going to do is you can create a Py file in Visual Studio Code, or you can just create it here. You got to make sure your view, show, and you want to make sure your file name extensions is checked, guys. Because if it's not, and you start renaming files, it's not going to work the way you need it to. It will hide the file name extension, and we need to specifically create a text file that has the extension of .py. So if we hide that extension, we're not going to be able to rename it with the .py. So you got to make sure you show file name extension. In fact, you're a developer now. This should always be checked. Whenever you get on a new system, that's like the newbie check mark. I don't know what I'm doing, so let's but that you want to have. So what I'm going to do here is I'm just going to right click, and I'm going to say I want a new, and I want a text document. Okay, and then I'm going to say chapter 2. Now you see it how it says .text. That's what we did. We allowed it. We're allowing us to see the extension. We're just going to call this chapter2.py. And it's going to change the type of file it is, and then I can actually, open it up and start editing it. And what I'm going to do now is I'm going to open up my Visual Studio Code, and I'm going to go to File, Open File, and then I'm going to go to that folder that I created, and I'm going to open up my chapter 2. And here we go. Now you see here, it's on C users, my desktop, chapter 2, chapter2.py. That's the way you want to do your files. You never want to create a file where you don't know where it's saved. Don't automatically create files inside of Python where you don't know where it's at. That's kind of it's going to set you up for failure. So especially when you get into reading from files and some other stuff in 202. So just getting these good work habits. Of course, if you're using Spider or whatever, those same steps will work for those programming languages too. Okay, first, good habits. When we declare a variable, we type in a variable name that we want, and then we assign it equal to a value like 3. Now 3 is an integer because we have different data types. Everything's a number, but there are different types of numbers. So if we have y equal to 3.3, those are two separate numbers. Those are two different data types. One is what we call a floating point. The other is what we call an integer. So when we get into the processing of data, and we're going to talk about input in a little bit, what you want to kind of have a recognition of when you're processing is that to process any two numbers, and when I say process, I'm talking about doing something like this. C is equal to x plus y. That's processing. We're taking two numbers and adding them together. But you see, I've caused a problem here because the CPU, when you load memory on the CPU to be processed, it has to be the same size. It has to be the same data type. It can't be a mixed data type. You can add an integer, a whole integer, to another whole integer. Like that. That will have no problems. But as soon as I were to take like x, which is just a 3, and add it to a y, a 3.3, we got a problem, because these are two different data types and they cannot be put onto the CPU for processing. So what we have to do is there's a conversion that happens. Now, there's either an implicit conversion where the interpreter will take and just cut off the 0.3 and truncate it, or the interpreter will detect that, hey, we need to just graduate this x to a 3.0, and now we can add them together. That happens on its own without you knowing. But it's something that you need to have a knowledge of, because sometimes the interpreter will just lose data for you and you won't know what's going on. So the idea of your data types when you process them having to be the same is a fundamental of computer programming, and every programming language out there has that issue. Now, some languages are better at converting one data type over to another data type before doing the process. Python is one of those languages. Remember, we're trying to make it easy. But there are still times when you have to specifically do something like take this y and convert it to an integer and then add it to x. Okay, so then what happens is we say y go become an integer, then add it to x, and now we should have that 0.3 we've explicitly converted the numbers to be the same. So it will truncate that 0.3 and we will have an output of 6. So I'm going to set a breakpoint here. A breakpoint is something that we can do to just kind of look at our code and what's going on with it. So what I'm going to do is we're just going to look at what C equals when we're done here, and then we're going to make a change. Then we're going to get into your input and your output. Okay, so it looks like a few things I'm going to get this thing going for inside of Visual Studio Code. Let's just run without debugging for now. Okay, so this is where I want a screenshot, is what your output is in your terminal. You have a little terminal here, and this is what I want a screenshot of. So we don't have any output yet. What we're going to do is I'm going to go ahead and do a print of C. Okay. And then I'm going to go ahead and I'm going to run it without debugging, and you see we got the value 6. But if I were to take this integer conversion out, what would happen is the Python will actually graduate x to a 3.0 and then add them together, and we'll get a 6.6. Okay, so now I'm going to go ahead and run, start debugging. Or wait, no, run without debugging. Come on. Okay, I don't like what it's doing, but whatever. Okay, so now I'm going to go ahead and run without debugging. Now without the conversion, you see we have our 6.3. So the big idea here is that everything's a number. When you do any kind of processing, subtraction, addition, divide, minus, the data types have to be the same. Or you have to have the knowledge that those data types are being converted in the background for you to make them the same. That's a big idea. So that's kind of a big idea with the processing. Let's get into our input, and I'm going to show you a few things. Let's see here. I think what would be good is to get into a little bit more on strings, starting out with a little bit on strings, because that's where we're going to get our first input. We've talked about processing. That's the main big thing for processing. When we get input from the user, it comes as a string. And I want to kind of demonstrate that with you. And what I'm going to do here is I'm going to grab some kind of input. And we're going to do something with the input. So to get input from the user, we can create a variable. In all variables, you want to create above. You never want to write code underneath variable in the initialization. So when you do your variables, you always put them above your processing. So here I got processing. I should try not to do any kind of variable creation or initialization unless it's up at top. Unless the variable itself depends on the actual values that you're assigning it, which C does. So let's go here with, I'm going to do a string called S. I'm going to say it's equal to, and here's where you get your input. You say I want to get some input, and then this is your prompt for the user. Now you notice I'm using double quotes. Always use double quotes for your literal strings. And what a literal string or any kind of literal means that we are literally typing it in. This is a literal 3. This is not a literal 3, but it has 3 in it. This is a literal 3.3 because we literally typed it in. This is not a literal. This is a string literal that we're literally typing in. So that gives you an idea of what I'm talking about when I say literals, because we're going to literally type it in. So enter a number. Okay, now this is kind of the thing about input is it comes to you as a string. So that's what I'm going to demonstrate to you through the debugger. By the way, when you do your strings, don't use the single quotes like it says you can in Python. Python says you can use the single quotes or the double quotes. I want you using the double quotes because all other programming languages use double quotes, and I want you to get in good habits. Don't start bad habits, because that'll carry over to other languages that you're learning. Okay, so we got enter a number. Now we're going to go ahead and run the debugger, and what I'm going to do is I'm just setting a breakpoint so that it pauses my process. And what this allows me to do is actually to visualize the mechanical nature of the process. And guys, if you debug everything and just start with debugging and go through everything with the debugger, you are going to have such an easy time in 202. It's going to be a breeze. So work on those debugging skills. So I'm going to go ahead and we're just going to talk a little bit about the debugger now. I'm going to go ahead and start debugging. And we can actually, you see the process is stopped, and we have not run this line of code yet. I have to do what's called a step over. And what the step over does is it runs the line of code and it moves on. So we've just created a variable called x equals to 3, and you see it shows up over here in my locals. I can also specifically watch for an x variable by adding that watch by typing it in. I could actually watch a whole equation without anything else. I can just put that in. I can add a watch of x plus y. What's x plus y? Well, y hasn't been set yet, so because we haven't run line 2, so we're going to get a problem here with a name error. But as soon as I do a step over, and this line runs, we've just set y, and now x plus y equals 6.3. Now we know what c is going to be. It's going to be 6.3 because we know the x is being graduated, and we're not truncating the 0.3 because the x is being upgraded to a floating point instead of an integer data type. Okay, so now I'm going to step over and we enter a number. Okay, this line hasn't run yet, but I'm going to go ahead and run it. Now here's one thing I want to do before we do run this is I want to show you over here in the locals. You see how these numbers are being represented. 6.33. There's no double quotes around them or anything. That means that these are actually numbers. And when I do an input here, I'm going to input a number and it's going to look different. Oh, I got to enter it down here. Okay, so 3.3. Okay. Good. All right. So I just entered S, and you see it comes up in here, our locals. We can also add a watch for S to see kind of what's going on with S. But you see the difference there. It's got single quotes around it. It's the same thing as double quotes. What that means is this input is a string. It's not 6.3. You see the 3.3 is totally different than that 3.3? This 3.3 is an actual number. This 3.3 is the representation of the number in its ASCII code equivalent. So when you enter in 3.3, what is actually happening is the character code 51 and the character code, where's the dot? The dot is in here somewhere. Okay, whatever. The dot is in here somewhere, and then you get the last three, which is another character code 51. And that's kind of the idea of input from all, and this works for all programming languages. It doesn't matter what programming language it is. All your input from a keyboard comes in as a string. So we can't do things like just take S and add to it. Well, yeah, we can. We can do something like string concatenation. We can say S is equal to the current value of S plus hello world. Those are string concatenations, and they're totally separate from doing a plus with just numbers. Okay, so a string concatenation. So when we run this now, we enter in our 3.3, and you see how the 3.3 got concatenated with the hello world because they're both the string. 3.3 is the string, hello world's the string. Okay, so but you're saying, oh, okay, Mr. B, I know that everything comes in through ASCII, and it's not actually a number, it's a string, and we can concatenate strings together, but how do I get it as a number so I can actually add two numbers together? And the answer is actually simple. You got to do an explicit conversion. You've got to tell the input, you got to tell Python to take the input that comes in as a string and convert it to the actual number you're looking for. Now in this case, we're going to do it as an integer. So I want to enter an integer, and let's say I'm going to enter 5. So I say, okay, take the input, convert it to an integer. After you've gotten the input, it converts to the integer, and then that is assigned to S. And now we have an error here because we're trying to take what is an integer, because we've converted it to an integer through an explicit cast, and we are trying to add it to a string, which is a big no-no. Well, the S is actually an integer, so let's add it to an integer. And now we have no problems at all whatsoever. Now you've got the floating point. You can do float here. That would be for 3.3. You would do float for 3.3. And then that would be a floating point number that you would expect from the user. But that's what allows you to add that +5 to it, because we're now loading those variables onto the CPU that are the same data type to process a result. And that's what processing is, guys. It's just taking same data types. You may get data in other forms that you got to convert. But whenever you're processing, you're always mostly doing multiply times divide, subtraction, and that stuff. Here's one that I would suggest that you guys seriously look into, because it is the best operator for computer programmers, and that is the modulus operator. It's the remainder of. Just take special note of that. It's probably the most important operator other than your regular plus, minus, divide, times. So of any of your operators, you got your modulus, which is remainder, you got plus, you got minus, you got times, you got divide. But here's the thing, when you do divide, what's going to happen? Well, if you divide an integer by another integer, the answer is going to be a floating point. So either S will come back as a floating point and graduated, or it won't. But let's go ahead and play with stuff in the debugger, and we're going to start debugging. Let's just look at things, how they kind of code process. Okay, so variables, we're creating all our variables and getting all our input up above. We do our processing, then we do our output. That's the same thing that you're going to be doing for all your programs. Okay, x is equal to 3, y is 3.3. We assign c equal to x plus y. That works. Now we get an input from the user. I'm going to go ahead and put in the value 10. It comes in as ASCII and it's converted. You see now that the 10 has no double quotes around it because that integer converted it to a number. Now let's see what happens with s divided by 5. We can actually just say s divided by 5 over here just to see what happens. S divided by 5. Well, that's going to become a 2.0. So it looks like Python is going to actually graduate the answer to a floating point because you're using division. Remember, like other languages won't let you do that without some typecasting. And that's what Python is for that capability to be able to easily graduate variables and work with each other. That's why we have Python. It's so that we have to deal with that nutty stuff because it does those implicit conversions for you to do simple conversions on numbers, even though they are different types of numbers that have to be loaded on the CPU particularly. And then you go to your output, and then what happens is this output, this S, that's the value of 2.0, is converted back to its ASCII code equivalent, a 2, a dot, and a 0 from the ASCII code map, and shown to your screen. So you're always dealing with getting input from the user in ASCII, converting that input if needed to numerical values. You could be asking for a string to use a string from the user, and you wouldn't need to convert if you did that. Doing some kind of process on that input, and then printing the output that goes and gets converted back right back to ASCII. Okay, so for today's talk, my main big ideas were to give you give you an understanding of what Python is, what input processing and output is, what does it look like, how does it behave, so we've met that for today. Now let me go into PowerPoint and see if there's anything else that we can talk about. String literals, make sure you always use the double quotes around string literals. Look into your comments. Comments are kind of important. They help me write code, and I call it code that I'm not testing yet. So I will comment it out with the hashtag in front, and then the compiler ignores those comments. I use that for when I'm just developing code and trying different things to get things to behave correctly. A lot of what you guys are going to be learning about is guess and check. You're going to guess how the code should be, and you're going to try to run the program and check to see if it works. That's how I learned the program. And guys, it's rough. The guess and check method sucks. Here's what I would suggest is get good at setting these breakpoints and working with them so that you do not have as much guess and check. Guess and check is not the way forward. Get right into debugging as soon as possible, and your life will be so much easier. You'll learn more, and you'll learn it better. And I just can't talk about it enough. Get into that debugging. Guess and check sucks. Okay, variables. Variables, remember, you assign your variables at the top, and when you give them an equals, that's when you set the data type of the variable. So like right here, we have age equals 29. Since the value is 29, that becomes an integral value. If it was 2.9, we would call that a floating point value. And we can have what we call a double value, a double floating point value, which means it's a floating point value that can hold large numbers, and that's why we call it a double. It's because it's just a float times 2 in size. So an integer data type is integral values, and here's where I would then go into, I wouldn't look at Python data types. I would look at C data types. And then I would look at the C data types. Then I would look at the Python data types. Because Python is just C, guys. So you can just, whatever. I mean, it's just C. It's a program that's already built to read your program in the C programming language. You just happen to use easier syntax, and a lot of things are done automatically for you. So you have these data types. The numeric data types are for integers and float, and then your text type is a string. You'll be learning about these data types later on in 202. A Boolean is just a simple true or false. And remember, to do any processing, these data types have to be the same. Like integer adding to a float, yeah, we can do it, but know that a conversion is happening behind the scenes for you. Okay, and let's keep on going down. See if make sure variable naming rules. You cannot have a number in front of the variable. Oops, wrong thing. Wrong thing. Get away. Go away. So if you declare a variable, you can't put a 1 there. And that's because the interpreter can't determine whether that's a literal 3 that you're just typing in like here, or a literal 1 that you're just typing in, or if it's part of the name. But if you put it after, if you have like x1, then the interpreter, x1, 2, then the interpreter knows, oh, this is a variable that's all together and I can handle it. It's only when you put the number above. And guess what? That is true for all programming languages. So that's something that's universal. And also, when you're naming variables, try to use names that don't suck. If it's a variable for adding the sum, you can do something like, variables can use descriptions. So let's say if it's like it's a variable that I use for a button click. I can say button _ x _ click or something like that. Or button, or how about this? Int _ x. That's a naming convention where you put the data type of the variable in front of the name of the variable. And that way everybody knows what it is, regardless of what you do with it. So naming conventions are very important in programming. And here's the reason why. Is because you're using so many libraries. What if somebody used the x variable in one of the libraries that you're using? They have a variable called x2. So you're using code underneath you in a layer. And what happens is we have name collisions where programs just stop working weirdly because we have the name of a variable that's the same of a library that we're using. And so they've come up with things like namespaces to make that, go away. And then, they tried saying that, okay, let's build all libraries and we'll put an underscore in front of all libraries. Well, then people started looking at libraries and they said, oh, that's cool. So I'm going to put an underscore in front of my X, and then the problems continues to happen. So namespacing issues are good. What I would like you to do is practice. If it's something stupid, simple like this, just use X or Y or whatever. But practice using names that describe the variable itself. Something like sum _ total. That is the total from a sum. Stuff like that. Use descriptions, and that way you won't have to have as many comments, to denote what your code is and what it's doing. Okay, and then you can use the print function to display multiple items. Let's look at that. Okay, so I can do print s, comma, c, comma, y. That's how I can do multiple items. I can also put in strings, hello, and then I can do a plus here, concatenate them together, world. And then what it'll output is it'll output S, C, Y, and then hello world after they've been added together and concatenated together. So I'm not going to debug this one. We're just going to run it to look at the output. Okay, oh, I gotta enter a number. Okay, so we got 6.8, 6.3, 3.3. Hello world. Okay, here's another real cool thing about print is the ASCII code characters. We're using ASCII code characters when we're printing stuff, and that includes things like the new line character. You know, like when you hit the enter key when you're typing things in a text box, and a new line happens, that's actually what we call a \n. So now look at the output. Okay, I'm going to put my number in. Okay, so we see hello, and then world is on a whole new line now. That's so cool. We can actually do new lines in here. Oh, we can do a \T for a tab. We've got all kinds of little text formatters that we can do in here. Here's my \T for a tab. Let's do \T. So a lot of what you have for formatting is based on that, even that ASCII code, because there's a tab character code in the ASCII code chart, and there's a new line character code in the ASCII code chart, and we can inject them into a string to have them behave a specific way when they're output to the terminal. Okay. Okay, here is my first new line after hello, second new line after the R, and then after the L is a tab, and then we got the D. Okay, guys, input, processing, and output. Data types have to be the same. You know that they're going to be the same, but when you're working with variables and a tertiary programming language, one thing that you are going to be working with is what we call the stack. And the stack is a regimented of memory that's given to you as your program starts up. And that memory is coming from the operating system, and it's your RAM that is used implicitly. So whenever you do a line like this, y is equal to 3, that memory goes on the stack, and it continues to go on stack until you're ready to use it to load it onto the CPU to be processed. So that when I use the term stack, I'm talking about that memory that's given to you when your process starts up. That's RAM, random access memory, and you don't have to ask the operating system for that random access memory. And when you're done, your program's done running, it returns that memory back to be able to be used by another process on the operating system. Okay, I think we talked about most of the crucial aspects of your input, processing, and output. I want you to spend some time on looking into a little bit more on mixed type expressions, data type conversions, but we pretty much hit everything big, or the big ideas from the chapter. Make sure that you pick up some of the things like named constants. Named constants is a test question, guys. There is no such thing as a named constants in Python. What we do in Python is we just create a constant by doing all uppercase. So that's going to come to you. You're going to have to do a constant in your final. And so some of these last little bit. Turtle graphics is fun. Play with that a little bit. You actually get into some real graphics in 202. But until we get on to our next video of Chapter 3, thank you. Goodbye.